Hi, my name is Joshua Angel, and I'm a computer science major at UC Santa Cruz. My host organization was the Center for Research in Open Source Software, otherwise known as CROSS for short. The project I worked on was an autonomous vehicle and sensor dynamic simulation with Gazebo. So the main goal of our project was to create a control system for various types of resource-constrained vehicles. Essentially, we wanted to create a universal machine learning detection system that could be used in multiple small vehicles. For this project in specific, we tested using a small RC car. So this machine learning detection system would be able to detect different colored cones and provide their known locations in real time. This is important because the software we developed would be available to thousands of people and can help other researchers. So my job was to create a simulation using ROS and Gazebo. I developed a fully controllable vehicle, as well as its sensors and cameras. I then created 3D models of the cones and placed them in an environment. This environment was then used to test our machine learning detection system and improve its results. So moving forward, we would like to take this detection system and implement it into different types of vehicles, such as RC boats and even drones. I would like to thank my mentors, Aaron Hunter and Carlos Espinoza, for helping me and supporting me throughout this internship. Thank you.
Hello, my name is Zoe Wolf. I am a rising fourth year undergraduate studying mechanical engineering at UC Davis. This summer, I worked as a mechanical engineering intern at CITRIS Robotics, and I worked on creating the concept and suspension design of a lunar rover. The goal of my internship was to design a suspension system of a rover for use on the lunar surface. Taking inspiration from previously designed rovers, this rover utilizes a passive suspension system, which means that the rover must overcome any obstacle it faces by responding at the exact moment it reaches an obstacle. The company that I interned at, CITRIS Robotics, is one of 14 companies contracted by NASA to bid on proposals to land payloads on the surface of the moon. This is all to the goal of supporting NASA's Artemis program, which has been described as the first step in the next era of human exploration. Success from NASA's Artemis missions will pave the way for humanity to reach its next goal, sending humans to Mars. In the beginning of my internship, I personally faced challenges of effective communication. I misinterpreted the challenges posed to me in terms of the tasks that I needed to complete, but throughout my internship, I learned what questions I needed to ask in order to clarify my confusion. The design of the rover began with an imagining of it in its most simplest form, a system of lines and circles representing the rover. From here, I did a lot of geometric analysis of the rover in various poses and situations, determining what sizes the wheels should be and how long the structural members should be. In my internship, my main task was to design a novel suspension system for the rover. This meant thinking outside of the box, and rather than drawing inspiration from existing mechanisms, to come up with completely new methods of joining the various structural members of the rover together and allowing the rover to rotate in the necessary degrees of freedom, all while staying within strict weight, size, and structural requirements. In the 8 weeks of my internship, I was able to design a passive suspension system for a lunar rover, but there remains much to do beyond this preliminary design stage. The design itself must be refined, and trade studies must be done in order to confirm the rover's robustness and its ability to traverse lunar terrain. The next step would be to 3D print or otherwise manufacture a physical model of the rover in order to determine the design's potential for completing the various tasks and operations that would be required of it on the moon. The most important lesson I learned during my internship was that a design process for a novel system, mechanism, product, etc. must begin at the most simplified version of what we're trying to achieve. This helped me realize the importance of forming a strong foundation on which the rest of the design is built. I'd like to say a special thank you to Michael Sims, Emily and Pat Dahlstrom, and Udit Shah for the guidance and feedback throughout this incredible opportunity. And I would like to also say thank you to the CITRIS program for allowing me to participate in such an insightful program. Thank you.
Hello everyone, my name is Junhao and I'm from UC Santa Cruz. In the past summer, I has been working with Calvi Design to work on their Streamliner project. And here's the picture of the Streamliner. So the main project focus here is the counter steering. So counter steering is a behavior that led the motorcycle rider to turn the desired direction opposite to where they are going. So this would allow them to turn at a higher speed and much more safer. So it is very unnoticeable, but especially when you are riding a bicycle, but it is very helpful to achieve a very stable driving experience. So in order to achieve counter steering, here are the three things that we need to take into consideration: wind detection, different drive modes, and leading angle. So we were trying to build up the algorithm to kind of to achieve this kind of measure. So for my part, as a computer engineering major, I was able to develop some counter steering algorithm using Arduino. So here's a snippet of my code. And I was able to have some hand-on experience into welding the circuits, also deciding the steering angle sensor. So originally we were looking for the one on the left side right down there, but later on we switched to the potentiometer, which would also achieve the same desire, but with a much more cheaper cost. And then I also done some testing with the DC-DC converter, which is also a main power supply for our Streamliner. So overall, I think the capacity of the project is much more higher than I expected. And as a sophomore, I was not familiar with the mechanical aspect of the project, so I was only able to do the software part of it. So which is kind of something that I'm missing out. But in the future, I would try to develop myself to a more well-rounded person, especially comes into the scientific mindset to come up with my own idea, my own optimization to improve the project in a better way. So thank you for listening.
Hi guys, this is Catherine, and over the summer I interned at Leap Photovoltaics, where my main role was helping in semiconductor physics through software engineering. So a bit of background about what the goal of this organization was is that because they're a green tech or solar company, so their main goal was to help revolutionize solar cells and the performance. So ultimately to help implement more efficient and effective clean energy. And so we wanted to be able to best model the solar cell performance. So the ultimate goal was to develop a process to manufacture crystalline silicon solar cells without wafers and instead using silicon particles. And through doing this, it achieves the same performance and reliability as traditional solar cells, but only using half the cost and entirely local supply chains. And by doing this, it would open up more accessibility and new markets, such as on cars or other surfaces for solar power. So how exactly my role fit in was that as a software engineering intern, I studied first semiconductor physics in the context of solar cells, and also regarding mainly how the main equations that govern ideal characteristics and performance in these cells, and also trying to learn about the various importance of different parameters, including physical and chemical ones, such as physical ones about the light, the angles, the distance, things like that, and chemical ones more about the materials and the properties. And also from this, I then derived and solved a system of parabolic and elliptical partial differential equations. And then using these PDEs, I then used MATLAB, and a PDE PE to ultimately plot and model the solar cell performance and efficiency through various parameters and physical conditions to best see under which conditions and parameters it performed best. So ultimately, what's next in this internship and in the process of like this goal is to expand from our current one-dimensional Cartesian coordinates to three-dimensional spherical coordinates. Like I mentioned, instead of using traditional like silicon wafers, which are flat and one-dimensional, we also want to use like three-dimensional spherical or like particle silicon cells. So by doing this, we want to go from no symmetry currently to ultimately azimuthal and zenith angular symmetries. So then from here, we will need to develop code for analyzing and improving the optical properties of the cell. And so this includes other ways of analyzing the problem, such as using like wafer ray tracers or calculating the photo-generated current density in a solar cell or testing the structure under a chosen illumination spectrum. Finally, I want to give a huge thank you to my mentors, Raja and Matthias. Thank you.
My internship focused on climate resilience, marketing in photovoltaic companies. My name is Janet Ramirez Rio. I'm from UC Merced, and my host company is Leap Photovoltaics. So big picture, motivation, and problem. What is the big picture? So I created a website for Leap Photovoltaics, which helped us display who they are, what they do, and why they do it. I also created a newsletter system for them. Any problems? So some problems that I ran into was finding out ways to make Leap Photovoltaics stand out from its competitors. So how did I get past this, and what was my motivation? So what I had to do was research other companies or their competitors to get an idea of what they were doing and see what we could do different or implement those ideas or make them better. And these are just some, like these images are just some examples of my research and how I like had to take my notes to implement it. So technical contribution and learning. Technical contribution. I created a new Leap PV website. I use Elementor, which is a website software tool that helps us create the website. To edit the images, I use a variation of apps such as Photopea and Sketchbook. And to create the newsletter templates, I use HubSpot. So what did I learn from this? I learned more about website development, how to create a newsletter, and the importance of marketing for a startup company. So next up in personal reflection. The next steps for this project and myself. Overall, the project I worked on this summer is ready to be finalized and published to the public. As for myself, I see myself doing more internships and working more in the marketing field. So this internship has definitely been a great hands-on experience to get a good understanding of what marketing is and how it works in the professional world. And finally, I want to thank Leap Photovoltaic and CITRIS for giving me this opportunity for being my first internship. I learned so much and grew as a professional. Thank you so much.
Hello, everyone. My name is Mina Dar, and I attend UC Santa Cruz. I am majoring in computer engineering, and this summer I interned at UCSC's Energy Optimization and Data Analytics Lab, where we used machine learning techniques for energy data analytics. So my internship focused on energy optimization and efficiency. One of the problems that my internship aims to solve is allocating the surging demand of limited resources available to our modern society. We focused on leveraging state-of-the-art machine learning techniques for energy data analytics, which includes forecasting electrical loads, energy prices, and renewable generation. So on the right, I have a word cloud visualization of our research, and on the bottom left, I have examples of renewable generation. I worked on many projects over the summer, the first being the economic dispatch problem. So the objective was that using the data from this problem, I created a neural network in PyTorch. I demonstrated the accuracy of the network by outputting the root mean square error, and I plotted it on a learning curve. So a learning curve is a plot of model learning performance over experience or time. So learning curves of model performance on the train and validation datasets can be used to diagnose an underfit, overfit, or a well-fit model. So on the right, I have an image of specifically an optimization learning curve, which means I was plotting the loss. Next, I learned how to use CVXPy to solve linear programs. I also solved the optimal power flow problem with the convex Python library and built a data set to train a neural network on that data. The objective here is that we are optimizing generation while enforcing line limits and minimizing cost. So in a lot of my projects, I created neural networks. And a neural network is a method in artificial intelligence that teaches computers to process data. I also wrote a script that will automate the data creation and neural network training process. And lastly, I created a simple convex neural network where the overall goal was to generate a dataset randomly and make the weight of a particular layer, in this case layer 2, always positive. So my mentors are going to continue where I left off, and they're going to be working on the input convex neural network architecture. I would like to give a big thank you to my mentors, Shoria and Kejun, for mentoring me through these 8 weeks and working with me on these projects. I would also like to thank Professor Yu Zhang for giving me this great opportunity. And if you want to view any of their research, you can go ahead and look at the website I linked on this slide. Thank you all for listening.
From UC Santa Cruz, and I was a 2022 summer intern for the BEST Center. That's Building Efficiency for a Sustainable Tomorrow Center. So the big picture of this organization is they educate college instructors about new technologies and innovations in building efficiency so that they can then pass this knowledge on to students who are becoming future technicians. And the motivation behind this is well, buildings make up about 40% of our carbon emissions, which is a lot. We need to reduce that by increasing energy efficiency, investing in insulation, handling chemicals safely, and the best center wants to make sure that technicians keep the climate in mind while they're practicing in the workforce, while they're working in the workforce. Because it's cheaper to just dump chemicals into the ocean, but we just want them to not do that by being educated about what it can do to the environment. And as for my time at the BEST Center, I authored a research paper on effectiveness of city-level enforcement. So I basically looked at municipal codes. I looked at the city's climate action plans, what they have done, how they've been enforcing the laws. For example, in New York City, there's a carbon cap. I just looked at how the city is enforcing that and whether or not it's been effective or not. Another project I did while at the BEST Center was optimize their YouTube channel. I basically just changed the titles and descriptions so that their videos would show up more in the YouTube search function. And one of the most fulfilling and best projects I've done was the member profile for the website. I basically got to interview a lot of the BEST Center's members and found out what got them to where they are, why they're with the BEST Center, because this is all optional. It's an optional organization. So I just really took a look at what motivates them to care for the environment and students. For my research paper, the next step for that is it can be revised. The data would just keep on being refreshed, keep on updating. All of the goals while I was doing my research, all of the goals were set for 2030. So as we're moving closer to that deadline, there'll be more data on whether or not the enforcement has been effective or not. And for the website and YouTube channel, I didn't get the chance to do this, but we could organize the playlist more and section the videos to be more specific, and so that people who go onto the YouTube channel can find what they're looking for easier. And special thanks to Peter Crabtree for guiding me throughout this internship, making sure my research paper is very professional, because this is my first research paper. And to Jim Aspenas for giving me the opportunity to work with 20 of the BEST Center's members and getting to interview and know them. Thank you to the BEST Center for all the work you do, putting in the extra hours, the extra effort to care for the climate by teaching our future technicians.
Hello, this is the CITRIS Workforce Innovation Program final presentation for our internship and project during the summer. We worked on the Dreamcatcher Career Hub, and our intern team is Eduardo Barato Mendoza, Kathleen G, and me, Justin Lee. Respectively, we're from UC Merced, UC Berkeley, and UC Santa Cruz, and our company is Future and Focus Incorporated.
During our internship, the problem that we aimed to solve was the disconnect between the education that learners were receiving and the knowledge and skills expected in their chosen careers. There's many ways that you could go about trying to solve this problem, but the way our company focused on was by changing the way education was being executed to minimize the gap between the two. And by partnering up with Future and Focus Incorporated, we contributed to building a proprietary library application that would help in minimizing that gap.
So this internship was our first experience working in a technical and professional environment. It was challenging for us to get out of our comfort zone and putting ourselves out there to give meaningful contribution. For example, during our meetings with the team, we were having a hard time figuring out what we can or cannot do to help with the project. However, the main goal from what our manager of the company wanted us to do was to just try. This really allowed us to experiment and explore what we were capable of doing as of right now. Nevertheless, we definitely have learned a lot from the internship. In this project, we employed programming languages and platforms that we were not familiar with. Therefore, during the process, we were able to not only learn new languages and knowledge, but also apply it to this real-world project, which we will make meaningful impacts. Through this valuable opportunity, we had the chance to improve our collaboration, communication, and problem-solving skills.
Some of the next steps for the project from the company is to continue working on the website by adding more features and improving the user interface design and connecting and learning about databases. For ourselves, we want to gain more experience in the future, build ourselves up technically and professionally, and definitely explore and expose ourselves to more opportunities down the way. We want to thank Mena, Steve, and Linda, and others in the company for this experience and opportunity.
Hello and welcome. The project we collaborated on as a part of the CITRIS Workforce Innovation Program was Repicture Summer STEM Career Accelerator. I am Michael, and the other interns who are also presenting this project are Lindsay, Jim, and Asai. We are students from the UC Santa Cruz and UC Merced campuses who work together at Repicture virtually.
During the Repicture STEM Career Accelerator, we aimed to introduce students to a variety of STEM fields that they may have possibly never thought of as a career path through panel sessions and mentoring. We also helped students develop skills that would allow them to create their own personal brand, network, and so much more. This is an important goal since most students interested in working in a STEM field don't know that it's not just knowing about that specific field, but also being able to communicate with people clearly, whether it's through writing or talking to someone in person.
In the Repicture workplace, we were able to put our soft skills into action by mentoring students, coordinating meetings and events, all while practicing our leadership. One of the main highlights during our internship was being able to interview students. We were able to get to know the students we worked with as a mentor, and we were able to help them practice for what an interview in the workplace would be like. The goal of this was to ask questions you may find in real interviews while moving into a more flowing conversation of the students' experiences and passions. Team projects of mentoring that we were able to engage in. We were able to work with students in a collaborative effort while also addressing any concerns or questions they had along the way. Besides these mentoring experiences, we also had the opportunity to give our share of slides and information to all the students during specific Zoom sessions. Whether it was addressing information about the Google Classroom, resume workshops, or even trivia polls, being able to speak to the students in this way was very helpful for further developing our own mentoring and teaching experience.
There were several STEM fields touched upon in the Career Accelerator, and one of them was digital health. There are multiple ways digital health was represented, as one of the goals of the program was to provide more exposure of STEM professions and projects to students. We needed to make sure that there was more variety of digital health projects. Some students already know about genetics and CRISPR, and telemedicine is becoming more commonly used, but the field is even more expansive. Something that I worked on was writing a project article about using AI in the drug development process for a cure for ALS, which is short for amyotrophic lateral sclerosis, which is a progressive disease that affects the nervous system and leads to loss of muscle control. Using AI allows drug researchers to consider more possible treatments than manually combing through the current literature about the disease and possible targets. Working on this project, I learned how AI can help find cures for diseases in addition to practicing my skills in writing about STEM topics. In the program, we also look to show students STEM professionals to look up to and learn their paths to STEM for different fields, which again includes digital health. During the program, Jessica Barnett was invited to be a guest speaker to discuss what it's like to be a digital health professional. She shared her career journey and advice with the students and exposed more career paths than is usually represented. Her path of coming from a communications and political science bachelor's to a master's of public health and later a master's of business administration that led to her currently working in the area of digital health innovation showed both us and the students that there doesn't need to be a direct career path in digital health or STEM in general, and there are different ways to still be able to take part in STEM innovation.
So next steps, the continued goal of the Summer STEM Career Accelerator course is to continue growing and incorporating feedback gained from the pilots in 2020 through 2022. Another goal is to make available to students an increasing amount of resources such as access to professionals, primarily driven through the growth of the Repicture network. My hope, personally, is to return as the peer mentor next summer so as to give back to the program and to further continue collaborating with them. We would all like to thank the CITRIS team as well as the co-founders of Repicture, Elisa Carr and Lynn Mayo. Thank you all to our viewers, and it was a pleasure to have the opportunity to work for Repicture.